Yes, fine. Fine, you are welcome to the chemistry first class. And under this particular chapter of nature of matter, we are going to discuss all this topic, content, and note. I am not going to be taking it extensively. When I say extensively, I'm not going to be taking it out of the syllabus. I will only limit myself to what is required in your syllabus. Now, for example, now the first topic says separation of mixtures and purification of chemical substance. Under this, candidates should be able to, the first one says, to be able to talk about pure and impure substance. So that's the first thing. Under this, the objective is to distinguish between pure and impure substance. So that is what I'm going to focus on. Then the next thing I'm going to talk about is the boiling and melting point as a factor or a criteria for pure and impure substance. So in a similar development, I talk about element, compound, and mixture. I'll be able to let you understand the difference between elements, compounds, and mixture. Also, I will also talk about differences between chemical and physical chain to identify them in question. And lastly, like I said, I'm only going to limit myself to what is going to be asked. Picture, videos, and something might not be shown in this class, but if I need videos to explain or to demystify further, I'm going to show you as well under the class. So we begin with the first part. The first part is classification of matter, pure and impure substance. Now, to understand this very well, we are going to write some notes down. And this, I hope you guys are with your biros, I believe so, and your notebook. So let's talk about pure and impure substance. I'll be writing, then, like I said, it's going to be in terms of short note. So when I say short note, you don't expect me to be writing everything that you're going to see in your textbook. I'm going to make it so simple and so direct. When I say simple and direct, I mean it's not going to be a kind of messy note. So I always want students to write like this. Let's start with the definition. So a pure substance. Now, a pure substance is based, you can actually enlarge your screen if you are not seeing well. A pure substance is defined. You can write pure substance. And I use abbreviation a lot, please. Pure substance is defined. It's defined as substances that has a constant chemical composition. A constant chemical composition. That's it. Another important point, you just write in this manner. It will really help you. You don't need to write too much of note. Just write it the way you can see aesthetic, then I'm going to give you points. Now, it is also free. It is also free from impurities. Impurities, or if you like to say from contaminant. That's also very important for you to know. Now, you can also write another important point that pure substances are categorized. Pure substances are categorized into elements and compounds. Pure substances are categorized into elements and compounds. Another important point, they can also be categorized. They can also be categorized into metals, non-metals, and metalloids. Now, when we say metals, we're still going to talk about, I want to get to the chapter of metals and non-metals. When we talk about metalloids, they are what we call semi-metals, or basically we call them semiconductors. So that's been that. Now, the first thing I want you guys to know is that, okay, when you say something is pure, that means definitely it is free from what? Impurity. And most importantly, it has what? A kind of constant Always keep that at the back of your mind because it's very easy to keep in mind if you are following. Now, another thing you can also let us talk about is when we talk about is some examples of pure substance, which I think is also going to be needed for you to understand very well. We can take a very simple example, pure water. Pure water is a very good example of a pure substance. Now, why do we say pure water is a substance? Now, it's a pure substance. The simple reason for that is because it has the same pure water. For example, water is H2O. You know that very well. It's an example. An example of a pure substance. The pure substance because an example of a pure substance because it has the same ratio. Same ratio of hydrogen up to oxygen. That's the same ratio of hydrogen to oxygen. So now, another important thing we can always keep in mind before we try to make a table is that any heterogeneous mixture will not be considered as a pure substance. And that is what will take us to what we call an impure substance. Now, for instance, when you look at a compound, which is another thing I want to talk about in the next slide, you are going to see that from early classes, we are told that compounds contain two or more elements that are chemically combined together, fine. Now, this substance can be easily be broken down into new substances. Elements cannot be split into new substances. So now, this will take us to what we call phases of what? Of pure substances. Now, when we say phase in chemistry, a phase simply means a kind of distinct molecular arrangement that is homogeneous. So when you say something is homo in Latin form simply means the same. Now, look at a very simple example of this is if I show you the arrangement of some molecules. For instance, you guys might have heard about what they call graphite and diamond before, under the allotropes of carbon. I'm very sure about that. But because I want to take it batch by batch, I don't want to rush you. You can actually say there are three phases in which we can actually classify a pure substance. So the next note I'm going to write for you guys is this. Just keep it simple. So as I was saying, I think the network is bad now. It's back now. I said there are three phases of I think it's better. I can still manage it. So now, in continuation to that, apologies about the network. Network is always going to be a problem at the beginning. But as we move forward, I'm very sure it's going to be stable. So I said there are three phases. There are three phases of pure substances. Which are, you guys know state of matter very well. So they can be in solids, they can be in liquids, and they can be in what? Gases. So it's talking about the arrangement of different substances and how they can be arranged. So in solid phase, we're still going to talk about kinetic theory of matter. We find molecules arranged in three-dimensional pattern. They are always clamped together. The molecules oscillate about their equilibrium position. That is that. In liquids, we say there is a little bit of spacing in liquid space, more like solid phases. The only difference is that the molecules are no longer in fixed positions. Now, in gases, I am not talking in details about them now because the topic is still going to be treated very well. Don't get to kinetic theory of gases. In gases, in gas phase, you will see molecules are farther apart from each other. In addition to that, there is no molecular order. They said they are randomly arranged. The word random is very important. And gas molecules do move freely and collide with each other constantly. So that is the phase. These phases are also what you see in. So the simple thing I want you guys to keep in mind for this is that pure substances do have the same constant chemical composition. They don't have any form of impurity or contaminant. They are categorized into elements and compounds. And they can also be categorized into metals, non-metals, and semi-metals, which is called metalloids. A very good example is the pure water because it has the same ratio of hydrogen and oxygen. And if you talk about phases, they can also be categorized into three phases, which are the solids, liquid, and gases. So in that sequence, we are going to quickly talk about impure substance. Now, the next one is impure substance. You can write impure substance. Now, let's just quickly talk about that too, because it's important we understand this before we start treating it the way JAMB wants you guys to know them. Because JAMB actually will not test you that you are to define pure substance, you are to define pure substance. No. What JAMB will actually test you guys on what are the composition of pure substance in terms of criteria of how do you know that this substance is pure, this substance is not pure. So what are those things that you need to look into? Those are the things that JAMB or UTME will test you guys on. So, but we are still going to get to that. I need to just let you understand something before I go into that. So impure substance are actually made up of atoms or molecules. So I can just write they are made up of tiny, let's just write of atoms or molecules of different types. First point. Another important point you can also write about impure substance is that what they are also known as mixture. They are also known as mixtures, or mixture as the case may be. Now, another thing is that what you can also write that what they can be, my network is so bad, but I believe you can still hear me. They can be easily converted. They can be easily converted into pure substances. So you can see the way I'm putting down the point. You can say using separation techniques, let's just write it in full, using different separation techniques, using different separation techniques. Note that. Now, another thing you can also write about impure substance is that they are also categorized. They are also categorized. They are also categorized. Give me 1 minute, please. I want to attend to somebody. Just a minute. So I believe I'm back. I'm having a call, but I think I'm back now. So I said they are also categorized into, that's the way I stopped, sorry. All of this. I think I'm back. Yes. Now, they are categorized. They are categorized wow. I don't know what is pressing. Something is pressing on my laptop. I can't write well. Okay, fine. I think it's back. It's better. They are categorized. Apologies about my handwriting. Just manage it the way it is. Into homogeneous. That is where we are going actually. Homogeneous and heterogeneous mixture. They are categorized into homogeneous and heterogeneous mixture with different composition. different composition. Now we can list examples if we want. Let's change to black. We can say, for example, AG, examples of that is we have an example of impure substance can be what we call soda lime or soda. Soda is a mixture of different things. You can say it contains water, sugar, and other flavors. I can just write like that. Another good example is gunpowder. All these things are gunpowder. Just write good examples. They are important to put it on, which is a mixture of sulfur, potassium, and carbon nitrate. And continue to give you many, many more examples of that. But the most important thing, like I said, all these are kind of preambles that I need to talk about before actually facing what exactly you are needed to know when it comes to JAMB. Now, JAMB don't actually ask you to define like WAEC, because I am going to be straight to the point. This I am doing for you guys is just for you guys to have a kind of a feeling of, okay, now we're in a classroom, so we have to talk about simple concepts before actually going into what is needed. So now I'm going to focus exactly on what exactly you are expected to know according to JAMB. Now, so far so good. What I've explained to you is that I'm trying to make a distinction between pure substance and an impure substance. And so far so good. I'm able to tell you that elements and compounds are classified under pure substance, whereby mixtures are classified under what? Impure substance. Other things I was able to tell you is what I believe you know before. That is talking about constant composition, whereby impure substances are not what? They have various or varying constant what? They don't have the same composition. They are made up of different compositions. So that means that, but to understand this very well, like I said, I am going to make something like a tabular form, which we explain in details, the differences between what do you call it, a pure substance and an impure substance. So what I will do for you guys is what I think you guys should keep in the mind. The important thing, JAMB way now. Now, let's try to make some kind of distinction. The distinction I'm trying to talk about is what is needed for JAMB. It is very simple. JAMB is not going to waste your time. Now, for example, let's just make a table to make this much more clearer, because I have a long way to go. So I wouldn't be wasting my time on teaching you what you can actually read in your textbook. I'll teach you what I know JAMB is definitely going to ask you. You understand? So I want to make a kind of table to explain that well. I think that will be the best thing I can do for you guys, at least for now. So now let's just see something. So let's say this guy is pure substance. And this guy is impure substance. So what you just need to keep in mind so that you can always get everything. Now the first thing is, we can actually separate, it's number one, the first thing is, this one has a constant composition. Constant composition. This one has a varying composition, that is, they are not in the same phase. Composition. So when I say that, that means not in the same phase. Because that is the language UTMA will use for you. When you say constant composition, that means they are in the same phase. So please always keep that in the same phase. Another point, which all these ones I'm putting under this table are what I want you guys to keep in mind, because that is what we are going to use to to answer questions. You get? Now, we said example of impure substance. This one is element and compound, which we are still going to talk about. Elements and compounds are examples. And this guy example is what? Mixture is a good example. That is also another point that I think is very important for you to keep in mind. Now, also, you can also talk about another important distinction, which you can also keep at the back of your mind, which I think you really need. Now, you and I know that it is very easy for you to separate a mixture, because mixtures have different compositions. So mixture is an impure substance, and because of that, very good example, you can say this one, they melt over, this you are writing a range of temperature, a range of temperature. Melt over a range of temperature. For example, most of the mixture do have a temperature range of about 573 Kelvin to 648 Kelvin. This is what I want you guys to keep down, because these are what you are going to see in your questions. Nobody will be asking you to define something. It is just direct point you need to know. Now, when you talk about a pure substance, this one, a pure substance, what we say is that they have a specific temperature. They have a specific temperature. Temperature is TEMP. They have a specific temperature, or you say they have a narrow range of temperature, because sometimes grammar can give you problem. Narrow range of temperature. So there is they are narrowly their range of temperature is being specific. That is why when we define this, we use some criteria to know a pure substance. Now, the criteria are what we are going to talk about in the next slide. So far, so good. The major difference I want you guys to keep in mind is that another point you can write is that these guys can be easily separated. Mixture can be easily separated by physical means, cannot be easily separated. So just write as number 4. Cannot be separated. So that is also an important point which you can keep down. So important thing for JAMB, all those things I've been talking about are the way you are going to be taught in your tutorial. But what you just need to keep in mind is, okay, pure substance are going to be in constant in the same phase. Impure substance are not going to be in the same phase. Secondly, elements are compound are classified as an example of pure substance. Mixture is a very good example of impure substance. Because of this, mixture can easily be separated. Pure substance cannot be easily separated. And then on top of this, which is a final point, mixture, which is impure substance, is an example of impure substance, melt over a range of temperature. That is, they don't have a particular temperature, and the range of their temperature is between 573 Kelvin to 648 Kelvin. Whereby for a pure substance, there is a particular temperature, and we now use a particular criteria to define what we call a pure substance, and that is exactly what I'm going to talk about in the next slide. So please keep that at the back of your mind. So let's move to the next slide. I hope you guys are actually getting this. Now, guys, let me ask you some simple questions before we move on. David, you have to unmute your mic. Any problem with this so far, so good?
It's all right, sir. It's very understandable and very easy, sir.
Lucas, do you have any problem? Newman, let me call you like that. You can mute your mic back. Any problem? Any questions so far?
I'm understanding everything so far.
You said?
No, sir. You have explained well, sir.
Okay, good. So
you have explained well, sir.
All right, let's move on. Now, into the next one or into the next phase, I'm following your tables. So I will be concise. I'll be straight to the point. Now, the next thing we want to talk about now is what we call the criteria for purity. Now, when we talk about purity or pure substance, now we have an idea about pure substance. Now, there is another important thing you must know. When we want to determine the purity of a substance, or how pure a substance is, there are some certain criteria we keep at the back of our mind. The first thing is, you can see I've already listed them out here. Look at the previous slide. I told you they do have a specific temperature, which is a narrow range of temperature. For example, pure water has a boiling point. You and I know that very well. That is, for example, pure water we boil at what? At the temperature of what? 100 degrees Celsius. Now, everybody knows. So what we are trying to say is that the first criteria for purity, to determine a pure substance, you can use what we call the boiling point is the first criteria. Boiling point. The second thing you can use to measure how if substance is pure is a melting point. And the third criteria you can write for now is what we call the density. Please, it's very important. These are the criteria we use to test for what if a substance is pure. Now the question is, now we've talked about this. Now, if a substance is pure, I'm going to make it very simple and very direct. Like I said, JAMB will not test you on something that will waste your time. Now, if a substance is going to be a pure substance, the first thing it's going to have a definite boiling point, or I say specific, you can say specific, or let's put it in brackets, specific boiling point. For example, we've talked about pure water as what? A particular what? Boiling point. So then if the substance is pure, when we talk about melting point, its melting point also, the melting point will be kind of what we said. Now, listen, there's this thing that most students used to ask me. Because UTME will not test you like saying, fine, you are to actually talk about melting point, boiling point. Is it going to be high? Is it going to be low? When I explained this to you guys, I told you categorically that pure substance is said to be 100% pure. And when it's 100% pure, you should expect it to have a definite boiling point. So nobody is telling you that the boiling point of pure substance is going to be high. It is always kind of moderate. So I'm not going to tell you it is high or it is low. That is that about that. Now, but if it is an impure substance, you expect the what? The boiling point to be kind of what? High. Why? Why do you expect it to have the melting point also to be kind of high? So boiling point to be low and the melting point to be kind of high. Why? Because it contains impurity. That is where we are going. And that is the knowledge JAMB or UTME is going to test. JAMB is not going to test about what is a mixture. A mixture can be separated, but that is what JAMB is going to ask me. How can you separate a mixture from a compound? A mixture can be separated from a compound by that. It's so simple. A mixture can be easily separated from a compound by looking at, okay, is it homogeneous? Is it heterogeneous? Does it contain same constituents? You understand? Can it be represented in a simple formula? Does the constituent lose their individual identities? You understand? Can it be separated by physical means? Is a property different from that of its components, and many, many more. Those are the things I have talked about. But I'm going to talk about them in details when we get about differences between element compounds and mixture. But for now, what I want you guys to keep in mind is that when you say something is pure, it has no impurity. It is impurity. Now, listen, impurity, effect of impurity. Let me talk about that. I think I need to talk about that before I actually explain more about melting point. Impurities, generally, impurities lowers, I think you need to write this, lowers the melting point, good point, the melting point of a solid substance. So generally you see in your textbook, if they write the impurity lowers melting point, but there's an exception. What makes you to be very good in chemistry is to know some exception. So the exception is it is only in solid substance impurities. So that is why the melting point of an impure substance is said to be about what? 570 something Kelvin that I give to you to 620 something. So you always keep it in mind that there is always an high melting point, another good point you can write, high melting point for an impure substance, because it contains impurities. So it's a good point for you to know. So we know that, okay, if impure substance has high melting point, what will be the effect on what? On pure substance. So you expect their melting point to be considerate, or you said they have what? A low melting point. I just believe you guys are getting how I am actually attacking all these things and trying to make sure you are getting them. So for solid substance, impurities lowers the melting point. Impurities will lower the melting point. So that means we are saying, for example, we can write in mathematics from the impurities is inversely proportional to melting point. I'll write melting point as MP. So let's write this one. We said, so if we add impurities to a substance, if the melting point is low, so what do you expect? That means if the melting point is high, immediately impurity is added to it, a solid substance, the melting point starts what? Going down. So please note that. Now, impurities lowers melting point. Now, there's a difference between range of temperature. Let me also explain this. You need to range of temperature. For instance, if you say a pure substance, I told you they have a definite temperature, and their range of temperature is kind of very short. You can say water can be between 98 degrees Celsius to 100 degrees Celsius. You can say they have a small range of temperature or definite range of temperature. But if you talk about impure substance, for example, what I gave you the other sometime, 578 Kelvin to about 645 Kelvin, for example, now, you can say this one is having a what? A wide range. Whereby this one is having a what? A short range. So now, get this. Pure substance have a short range or definite range of temperature, but impure substance has a wide range of temperature. This is because we said impurities lowers the melting point in solid substance, but increases the melting point in liquid. You can write impurities, please write this, impurities increases the melting point of liquid substance. So now, what are we trying to talk about under this slide? What I just want you guys to know, keep in mind, is just 3 things. Number one, to determine if a substance is pure, we use 3 major criteria. The first criteria is what, or criterion rather. The first criteria is boiling point. When we talk about boiling point, a pure substance, we have a particular, a fixed boiling point. That is what we're talking about. Now, the second criteria is its melting point. Now, melting points are kind of differs depending on the composition or the nature of of that type of substance. For example, if it is in solid state, impurities will lower the melting point. If it is in liquid state and gaseous state, impurity tends to add to the melting point of liquid substances. So these are things that you need to keep at the back of your mind when we talk about all this stuff. So keep it in mind. Melting points differs from each other simply because impurities are going to have different effects on solids, on liquids, and on gases. So that is the way it is. It's always keep that back. So now, the next thing I want to talk about now, because I don't have time, I have to finish all these things. There are lots and lots of things to talk about. The next thing I'll talk about is going to be in the next slide. Now, the density. Let me talk about the effect of density. The effect of density on what? On purity. So now, what do we call density? Now, everybody should actually have about density. Most especially in your physics, you say density is what is defined as the ratio of mass per unit volume, or mass over volume. Density is mass over volume. So now, how does density have effect on pure substances? Let's talk about that too, because it's not all that common in your UTME, but let's talk about that because it can come out in different forms. Now, how does density actually have effect on pure substance? Let me use now we talk about pure substance, we say it depends on the mass, on the size, and the shape of molecule. So if you actually want to talk about how density we have effect on the pure substance, that means we need to consider a lot of factors. Listen, a lot of factors are to be considered. For example, if you want to talk about the density of a pure substance, the density of a pure substance will depend on, just write density, let me write it down, of a pure substance. Density of a pure substance depends on, you can say first one, the mass, you can say the size, and the shape of molecule. So what am I trying to say, my dear student? What I'm trying to say here is that you cannot actually say this is going to be a particular effect of density on the substance. It varies from that nature of that particular substance to another, because density is mass over volume from your knowledge of physics. So if you are dealing with effect of density, that means you must talk about other factors like pressure. I can also let you write it down. Pressure and temperature, which we are going to talk extensively when we get to the kinetic theory of gas. So for now, why most of your teacher will only focus on effect of boiling point and melting point and not talk more about density when you are doing pure substances is because the variation of density on pure substance depend on a numbers of factors like its mass, its size, and the shape of molecule, which can further be demystified when you talk extensively on kinetic theory of matter, talking about effect of pressure, effect of temperature on different states of matter. So that's been that. I don't want to also waste my time. Like I said, we do have a long way to go, and because of that, we need to up our pace. So the next thing is what I'm going to see in the next slide. Let's see what we have in the next slide, so that we will be able to talk very well on what is actually needed. So my connection is always unstable in the night. I don't know why, but I know I'm going to get a better connection. Now, about elements, compound, and mixture is the next slide. About this slide, I'm not going to talk about too much of things. I'm only going to focus on some stuff that I think you guys are well, let me say you are well grounded in this area, but I only talk about what UTME will ask you. Like I do tell students, it is all about what UTME is going to ask you. It's not about what you guys have textbooks. You can always read, but I will teach you what exactly you need to know, and you are going to see them when we start treating questions. So basically, I'm going to talk more about the differences between compounds and mixture, because it is what is giving us compounds and mixture. Why am I talking about compound and mixture? I told you this compound can be classified, elements and compounds can actually be classified as a pure substance. And this guy here can be classified as an impure substance. The third students should have joined us now. I don't know why, what is keeping him. He said he's going to join by 8:15. This is 8:15. So now, when we talk about pure substance or a compound, basically just let's write some important things, which I think you just need to keep. Just write this down. It's important. You know, compound contain two or more elements that are chemically combined together. Definitions are not that important in JAMB. Yes, application is what is important. Definition might not be important in UTME. Yes, I said so. Yeah. Now, always keep it in mind that what the composition of a compound and element will always, just keep it in mind, always homogeneous. Homogeneous. So they are only, for this one can be homogeneous or heterogeneous. We talked about that, heterogeneous. So talking about the next one, I talk about same constituent for this one, same constituent in the same proportion, same constituent in the same proportion or ratio, or you say ratio. For this guy, for mixture, I told you varying constituent, and no specific ratio. The third point I'm going to talk about here, which I think is also very, very important, is when you talk about this one, this compound can easily be expressed. Let's keep in mind, can easily be expressed as a formula. For example, if I say you guys should write sodium chloride, you guys know sodium chloride is NaCl. And sodium chloride is NaCl. Because sodium chloride is NaCl, you can easily write it as a formula. But when it's a mixture, element can also be written as a formula. A mixture cannot be easily expressed. Always keep that in mind. So cannot be easily expressed. Now, the next one is another thing you need to keep in mind, because I wouldn't want issues when we are talking about, when we start question on this. Compound constituent, you can just write it, constituent of compound, constituent of compounds. This is also very important, not in your textbook. Constituent of compounds easily lose their identities, easily lose their identities. They easily lose their identities, whereby this one, you know, it will be opposite, constituent retain, yeah, good evening, welcome. Yeah, retains their identities. And maybe I should talk about one more. Let me give you one more. I can give you as many as you want. Another thing that is important is that the property is different. When you talk about the properties of mixture, it is the same thing as the sum of their component. I can just talk about that. It's the same thing as the sum of their component because they are going to be what? Distributed in the different components. That's why they can easily be separated. But properties of this one is different from that of their component. In compounds, their properties are different from that of the component. Now, here you can also say compounds are chemically combined together. That is O level. Compounds are chemically, compounds here are not chemically combined together. That is definition. You know that. Then the last one I'm going to write, which is the most important one, is that this one components cannot be easily separated. Components cannot be separated. We say cannot be easily separated by physical means, not that. So components can be separated by physical means. So that is what I want to talk about when we talk about compounds and mixture for now. Elements, you know, there are lots of elements in the periodic table. There are 118 elements in the periodic table. For now, we are not in periodicity. When we get to the chapter of that, we are going to talk more about elements. So for now, pure substance are elements and compound, impure substance and mixture. So this also can give you some distinction between pure substance and impure substance. So in a similar note, I won't talk more than this on this. We move to the next one. Now, talking about the next one, very good. Now, on the next one here, we are talking about physical and chemical change. I think this one is also very important. Now, we talk about different states of matter the other time, different phases in which we can categorize elements and compounds. We said solids, remember that, liquids, and gases. Like I said, when we get to the topic or the chapter of kinetic theory of matter, we are going to talk extensively on this. But for now, when we talk about physical changes and chemical changes, basically, we are focusing ourselves on mixture because mixtures are those that contain different components. They are the ones that can be easily separated. They are the ones that do have heterogeneous mixture. Sometimes they can also have homogeneous mixture. I told you compound or element will always have an homogeneous mixture. Keep that in mind. Now they are the ones that their constituent varies. Because their constituent varies, that means we need that we can actually separate them from one point to another. So now any substance that can easily be separated, you and I know, is called a mixture. And that particular thing, aka another name for mixture, is what? An impure substance. That is what you have learned so far, so good now. And you know that impurities, we have what? Effect on what? On criteria, also on boiling point, on our melting point. Especially if it is a solid substance, it will definitely lowers the melting point. So what we just want to talk about here is also a very simple thing, which we believe also you have actually talked about in your junior classes. Yes, I am sure you have talked about that. That is making a distinction between a physical change and a chemical change, and also giving an examples or different examples of physical and chemical change, because JAMB, which this is topic 1, is going to ask you a lot of questions on which of this is a physical change, which of this is a chemical change. Now, to avoid you mixing questions, to avoid you giving examiners some useless math that you are supposed to get, so that is why we want to talk about this. We know some of you actually do have an idea about how to differentiate between a physical process, that is a physical change or a physical phenomenon, and a chemical process or a chemical change. So now, when we talk about physical change, just like what we've talked about, a physical process, we say, does not actually require a lot of composition. A physical process are processes that we can say, number one, important point is just what I want to write down, is that number one, they are easily reversible. That is, they are mixtures. They are easily reversible. So the opposite will be this one. They cannot be reversed. They cannot be reversed easily. So they cannot be reversed easily. They cannot be reversed easily. Now, another key point you can also keep in mind, number 2, is that for this one, for physical change, you will say there is no change in mass. These are elementary stuff. There is no change in mass. For this one, it will be the opposite. There is a change. There is a change in mass. Another key point which you can also keep in mind, number 3, I'm giving you 4, is that for this one, there is no new substance formed. Very important, no new substance formed. No new substance formed. And for a chemical process, there is what? A new substance. A new substance is formed or produced. Anyhow you want to write that. A new substance is formed or produced. Then number 4, which is also very important. This for physical change, we say no heat loss. For a physical process or a physical change. For chemical process, we say there is a great amount of there is a great amount of its loss. So these 4 distinctions are the elementary or the basic or fundamental knowledge that distinguish between a physical process and a chemical. So a physical process can actually be said anything that can be separated, that is any kind of impure substance can a physical change. For anything that require an amount or a great amount of heat can be said to be a chemical process. Anything that is producing another substance is said to be a chemical process, and so on and so on. Now, to understand this very well, and for you not to have troubles, I'm going to give you some examples, some popular questions example that you are going to see, because with examples, I know you guys are going to have confidence. So to do that, I'm going to move this guy up so that I'm going to have a space to actually, I believe you are true with writing. You have to write fast, because I'm using a writing tab to write. So you are using biro and pencil, so you should be able to write faster than I am. So let's give an example. Let's give a lot of examples of physical processes and chemical processes, which I think you need to understand. So I'm going to start now. Whenever you just always keep it in mind, there's a shortcut I always give students for this one, but you are not writing one. Just remember RFMH. You can keep it at the back of your mind. Reversible, new substance form, change in mass, heat. All these ones are for chemical process. The opposite is always for physical change or physical processes. For example, you say chemical process cannot be easily reversed. They lead to formation of new substance. They require great mass. They require great what? Great heat. So the key point now is RFMH. We always give you a quick reminder to actually differentiate between chemical substances or chemical processes and a physical process. So be that as it may, like I said, I want to list example of what? Of physical change. You can also keep a note, just a note, nota bene, that any change of state is important. Change of state is a physical change. So I'm the one that says so. You'll keep it. You can quote me. That's why I always highlight my point. So any change of state is a physical state. So if something is changing from one state to another, it is going to be what? A physical. So let's talk about examples of chemical change. And please write examples of chemical changes or chemical process. So that it will be very, very easy for you when you see questions, you will just attack them directly and make sure you get it. The first one is burning of wood. Let me just write some simple examples. Burning. Why is it physical process? Burning of wood or burning of anything. It's not only wood. And the destructive distillation of wood, whatever, anything that involves heat is going to be a chemical process. So please note that. Number 2, I'll talk about dissolution. Please note. Dissolution of metal. Dissolution, yeah, this one is very important. Dissolution of active metal. The solution of active metal, solution of active metal in cold water. So let me also move up a little bit so that you guys can actually have enough space to write. Now, the third one, now, how is this one? Because most of you are always going to, well, my teacher told me in secondary school that the solution is a physical. No, no, no. Now, let's take any method, for example, now, and let's dissolve it in what? In water. Now, in cold water. For example, look at this, equation of reaction. You're going to say, let's say sodium is Na, sodium is a metal. You and I know that. It's reacting with water. Sodium reacts with water. We are dissolving sodium in water. We are going to have sodium hydroxide, NaOH, and we are going to have what? Hydrogen gas. You have to balance equation. I may not be balancing now because I'm actually working with time. 2, if you put 2 here, and I think 2 here is balanced. You can say sodium was dissolved in water. That is the word dissolved in the solution. Was dissolved in water. And when it went in water, it leads to what? Formation of new substance. New substance is formed. So when new substance is formed, that particular change is said to be a what? A chemical change. But if I say dissolution of what? Of salt in water. If you dissolve salt in water, are you going to form a new substance? You and I know that it is not possible because you can easily separate salt and water. Anything that require a change of state is a physical state. So salt and water can easily be separated, which is going to be our last slide. Now, if you can easily separate one particular state of matter from the other, if something is a mixture and it's not leading to a formation of new substance, such process or such particular phenomenon is called a physical change. Now, other example of chemical change, because you need more and more, is I can continue to list passing of steam. Why I'm doing this is because it's going to help us in future process. Passing of steam over red hot coke. Or you say red hot iron. When steam is passed over red hot coke. That one, I know you guys, some of you might have, let's take iron, for example. Iron is Fe. Then you pass steam. Steam means water that is in gaseous form. So just listen. So when you do that, you can see iron combined with water is going to give us Fe3O4. This is iron 3 oxide plus what? Hydrogen gas. It is leading to a formation of new substance. It is a what? It is a chemical process. So let's pass steam over red hot coke. Now, when steam is passed over red hot coke, is carbon. It's an allotrope of carbon, first carbon to be precise. It's passed over steam. Steam is H2O gas. I did not balance equation. You can always balance that. Not that I can't balance, but because of time, I think I've taken you guys for 1 hour now, and I have to take you guys for 1 hour 45 minutes before you start your question and answer. So, I'm still having some kind of stuff to talk about, which I've not talked about. So that's why I'm not wasting my time balancing chemical equation. Not that I can't balance. I'm still going to teach you that when we get to that chapter. Now, moving on. When carbon or when coke, or you say when coke when coke is passed, or when steam is passed over red hot coke, you are going to have what we call, you guys know what they call water gas, producer gas and water gas. This is carbon monoxide and hydrogen. So because it is forming new substance, any reaction that is forming new substance is classified to be a chemical change. Another good example you can always see in question, which you have to keep in mind. I'm writing them out now because I don't want you guys to be having problems when you are thinking, is this a physical process? Is this a chemical process? It's what we call slinking of lime. It's also popular, and because it's going to be important in our future understanding of chemistry. I'm sorry, I'm rushing now because of time. Now, slinking of lime. Now, when you say you slink lime, what that one simply means is when you have what we call a quick lime. Calcium oxide is called quick lime. It's now dissolved in water. So when you react this, you are going to have what we call slake lime. Slake lime is called calcium hydroxide. It's written as COOH or twice. CaOH or twice. So slaking of lime is an example because it's also what? Look at this one. This guy is called quick lime. If I'm right, they are going to be needed in our future topic. And at the end of the day, it's giving us what this guy is called slake lime. So any reaction whatsoever that is leading to the formation of new substance is called what? A chemical process. It doesn't stop there. Let me also add to it. Why I'm also adding to it is because I want you guys to just watch when we start our multitude of questions, our questions and answer, you are going to see a lot. The next one is eating of lime. So when you see the word eat, my dear student, don't waste your time. It's a chemical process. Eating of limestone is definitely going to be a what? heating of limestone. Limestone is, why I'm actually writing the equation of reaction, because I want you guys to get used to some things. Now, this is iron 3, this is iron, this is water. Now, this is coke, this is carbon, amorphous carbon coke. Is what? Steam. When you put gas, water in gaseous form is steam. Water in solid form, water in liquid form is just your normal water. Sometimes you say cold water. You understand? So when it starts giving vapor, you say it is what is in gaseous form. So heating of limestone. Limestone is written as what is also called gypsum. We can also need that later, but for now, I think let me just be writing them because you might need them later. JAMB is so what? So what? Crazy. Now, when you eat CaCO3, you call it CaCO3, CaCO3. You and I know it's going to what? Decomposition, decompose to CaO, which I talked about. What is CaO? Quicklime, and CO2. What's that? That is our carbon 4 oxide. So many more things can still be added. Addition of water to, let me also add, just because I know these people very well. I know them. Addition of water. This right, addition of water to calcium carbide. That is production of ethyne. Addition of water to calcium carbide. This calcium dicarbide. So this one is also very important. This is how we produce ethyne, an organic compound, which we are still going to talk when we get to the chapter of organic chemistry. Look at the CaC2 combined with what? Now, this is going to give you new substance. The new substance you are going to form is calcium oxide, which is called quicklime, plus calcium oxide plus, that is ethyne, C2H2. This guy is called ethyne. I know you guys, you have idea, but you are going to have more idea with me, and that is why I'm here to make you guys enjoy chemistry. Now, the next thing is another example. You can see all these examples I'm listing are giving me new substance. But why I'm writing equation of reaction is that this reaction are one of the most important reaction in what? In UTME, in JAMB. So you have to know them. You have to know their reaction. You have to know how to write their equation and how to balance them. That's why I'm listing the example because we are going to need them further or in what? In future what? In future what? As a future reference. When we get to some topic, when we get to what? Extraction of metal, classification of metals, classification of metals and non-metals, all these things are going to be talked about extensively. Another example of reaction is what, which you also need to keep in mind, is a chemical process, is charring of sugar. Charring of sugar. Now, charring of sugar is also popular under organic chemistry when you are doing carbohydrates. Now, sugar is said to be containing of a carbohydrate, sucrose, which you write as, let me write the equation of reaction, 6,6. You guys know that. H12, O6. This is glucose. Now, charring of sugar means adding sugar plus concentrated H2SO4. Now, what we notice is that when sugar is combined with H2SO4, we are going to see something as a black residue. That's why I call it charring. I know this one you guys might have heard about it in your secondary school too. So when we add sugar to what? To H2SO4 concentrated, it's going to give us carbon black, 6C. That is carbon. You can see charcoal plus what? Plus water. I'm balancing. So when you have new substance, you know it's always going to be a chemical change. But I'm not actually facing chemical process now. I'm only trying to teach you some reactions which are needed for you to be known as a chemistry student. Another chemical process to add to it on top of this is fermentation of sugar. Fermentation of sugar is a chemical process. You can continue to add and add and add and add and add. Another one I can also add, I can also help you guys add what we call redox changes, redox reaction. All these redox reaction. Reaction is RSN. No time to check time. We have a lot of things to stick to. So keep it in mind, dissolving something, adding acid to something, adding something to something. In as much you are adding and you are producing new substance, my dear students, I beg you, it is going to be a chemical change and not a physical process. So you shouldn't have any problem. And I told you to know a chemical, to know a physical process, always just keep one thing at the back of your mind. That is what any change of state is a physical. When there is a change of state, it's going to be a physical change. And most physical change are one that does not lead to the formation of new substance. So now, so far so good. Before we move to the last slide, we have learned a lot about, we started, let me go back. Yes, I think we started from pure and impure substance. We were able to identify the definition of pure substance as those that has constant composition. We gave an example of elements and compounds. They don't have impurities. A very good example is water. We also talk about it can be classified into phases of solids, liquid, and gases. We then move into impure substance. We say they are made up of different atoms, can be that are heterogeneous. They are also called mixtures because they can easily be converted into pure substance and they can be separated by different separation techniques. We categorize them into homogeneous and heterogeneous, and a very good example of them is solely a mixture. So we give an example of soda, which contains water, sugar, and flavor. I also talk about gunpowder, which contains sulfur, potassium, and carbon nitrate. So I was able to differentiate between pure substance in JAMB form, in UTME standard, in terms of constant composition and varying composition. When we say something is constant composition, that means it maintains the same phase. Thereby, varying composition is what nothing is in what they are not in the same phase. So now, I also talk about examples of pure substances, elements and compounds. And later, I was able to differentiate between compound and mixture. I gave you different similarities. We have different differences between compounds and mixture. I gave you talking about a compound will always be homogeneous, whereby a mixture will always can be either homogeneous or heterogeneous. I also talk about their constituents. Constituent of a mixture will always vary, whereby that of what? Of a source. So impure substance and mixture, just keep that in mind. So I continue talking about this. I talked about the criteria for pure substance. A pure substance, we majorly use boiling point and melting point. I told you the third factor is density, but density of what? Of a substance depends on the numbers of factors. I made mention of mass, on size, on shape of molecule, and most importantly, the pressure and temperature, which we are going to talk about on the kinetic theory of matter. So these I was able to tell you that melting point do affect the what? I told you impurity do affect the melting point of a solid substance. It lowers the melting point of a solid substance, but it increases that of a liquid substance. I also let you know that when we talk about impure substance, they melt over a range of a wide range of temperature. Pure substance will melt over a definite amount of temperature. So keep that in mind. So that now takes me to differences between compound and mixture, which I just explained now. And I told you there are a lot of about 118 elements in the periodic table. When we get to the chapter of periodicity, we are going to talk extensively on that. What I just want you to keep in mind is that mixtures can be easily separated, whereby elements and compound cannot be easily separated. And that is what now led us to what we call the physical change and the chemical change, which is what I was talking about here. And I was able to give some distinction between them by talking about different phases. I also talked extensively, letting you know that when something can actually change its state, it is classified to be a physical process. The major 4 differences, shortcut, is the RFMH principle, reversible, substance form, mass, and heat loss. If you are able to know these 4 principles to identify the chemical change and physical change, it's not going to be difficult. And I said in UTME standard, students are allowed to actually know numbers of examples of reaction. I gave you the popular ones, which you must keep in mind. And these are passing of steam under red hot coke, the action between iron and water and steam, the action of dissolution of metal in cold water. I told you dissolution of salt in water will not lead to formation of new substance. And that is the reason why that particularly do confuse some students, because some students cannot also differentiate between a mixture and a compound. And I was able to do that in the last slide. I was able to tell you that if you want to differentiate between a mixture and a compound, always know that you can easily write a compound in a formula, but there is no formula for a mixture because it contains 2 or more compounds. I hope you guys understand so far. Apologies for the fact that I am rushing you, but because this is a foundational course, I believe you have an idea, but I have talked about 1 or 2 things that you don't know before that I'm very sure about. Before I move on, I'm going to call your names and I want you guys to respond if you are getting it. Now, the first person I'm going to call, so far so good now, is David. That's David. Any questions so far before we move to the last slide, which is separation of the... Any questions so far so good? I can't hear you. David, you are not talking, or I guess it's your network. David, your mic is not moving. I don't know why. Okay, let's move to the next person. Newman, how about you? Any question so far?
Yes, sir.
Okay, fine. Your question, please.
I just wanted to ask, I understand everything that you have been saying so far, but I wanted to ask is that in the physical change and chemical change,
okay,
you said no heat loss. I want to ask, in all physical change, there cannot, is it possible that there cannot be a single physical change that there will be loss of heat?
Okay, fine. I love that. That is a kind of technical question, which I love. It shows you actually know what you are saying. Now, I think the language should have been no great amount of heat, no great heat loss. I get it? No great heat loss. Now, in physical process, definitely you can't say, talking about thermodynamic process and other things, you cannot actually talk about maybe a physical strain will not actually lose. Yeah, they can actually lose heat, but they don't lose great amount of heat. How about that? Is that language understood now? They can actually lose heat. And that is why you can actually convert one form of energy to another. You know that the next topic, which is our topic 2, that is particulate nature of matter. Under that, we are going to talk about different types of chemical formulas, equations, and different chemical reactions and different laws. Now, definitely physical change can lose heat, but the amount of heat they are going to lose is we can say it can be negligible. Do you understand now? So if you have a question,
yes,
yeah, they can actually lose it, but not, you can see the definition I gave you, great amount of. That's good. Now, next person I have here, so far so good at Lanre Waju. Do you have a question? Please unmute and answer.
No, sir. No, sir. No, right, for now, sir.
Okay, no. Okay, David, I don't know if your mic is now okay. At David, unmute and talk to me. Any questions so far so good? David, you're having difficulties with your audio, and that will not be will not be okay for this class because I can't hear you. So I don't know what happened. Maybe you can just mute your mic back and check your network. I think your network is kind of but if your network is bad, you should be out of this class. You understand? But if you are still in this class, I think something is happening to maybe your earpiece. Maybe you remove your earpiece and just connect your phone directly. Maybe you do that because I'm not hearing you at all. So maybe your earpiece is okay. So
yeah, I've removed the earpiece now, sir.
Now I can hear you now. Very good. Now, any questions so far?
There's no question now. There's no question now, sir.
All right, fine. So let's move to the next slide. Now, about the next slide, which is the last slide. That is the last slide we call the separation technique. Now, like I said, I am a kind of teacher that is coming here to come and explain concepts to you. I'm supposed to stop this class by 9, and you guys are going to do. I have 15 minutes more. Now, if I am going to explain separation techniques, like I said, I'm only going to focus on what you need to know. Like I said, if you need a video to understand extensively what I am talking about, I am going to show you the video to accurately make you understand it well so that you won't have problem. But my dear student, what you need to know here about UTME is very, very simple when we talk about separation technique. You and I know it is mixtures that can be separated. So far, so good. We've talked about that. And so far, it is mixtures that can be separated. One thing we need to keep in mind is that these mixtures we are talking about that we want to separate, there are some particular things that we can as well keep at the back of our mind because there are different separation methods. Now, before we delve into that, we need to understand what we call a kind of, let me use something like this. I think it will be better if I use something like this. We said we can categorize mixture also into 3 phases, solid, liquid, and gas. That doesn't mean we only have 3 states of matter. We can have more than 3 states of matter. But for now, let's just keep it like that. I won't talk more than that. Now, let me just draw some state of matter and their change of phases and the name we give to them, which is what you guys have actually learned in your junior classes. I am very sure about that. You guys will be like, I love saying junior classes because I know you've learned a lot in your junior classes. So let's just do something, a reverse of process, and same thing to this guy too. And let's leave this guy the way it is. So I'm going to write some kind of, let me use green. So here we are going to have, let's say this is solid, the first state you are writing. This is liquids, the second state, or you say liquids, or let me make this state gaseous because I only have one arrow, so that it will make sense. So this is gas or gaseous state, and this guy is liquid. So these are elementary things you've learned in junior classes. When substance moves from solid to liquid, it goes without saying, you guys know the process is called melting. Very important. Now, when it's moved from liquid back to solid, please watch the direction of arrow. We say that thing as what is freezing. More of this will be discussed more under this class. Now, when substance moves directly from solid to gas or gas back to solid, we said it as sublime. That is sublimation. And when we talk about substance moving from liquid to gaseous, we take it as what? Vaporize, vaporization. Vaporization. And if it is in other way, if it has moved from gas to liquid, we say it has what? Condensed. So we say condensation. So these physical processes are very important for you to understand some methods and some terminologies that we use in separating. Now, another physical process I can talk about now, which I think is also important, is that we have definition of what we call, apart from homogeneous and heterogeneous mixture, heterogeneous, that is same phase, not in the same phase. We've talked about that. We also have what we call mixable and immiscible. You can see the way I'm doing immiscible substance or liquid. So from the word, from the name, liquids that can easily mix are mixable. Those that cannot be easily mixed are immiscible liquids. I hope you guys are following. So now, all these things are very important when we are talking about phases or what separation techniques. Now, the major separation techniques we are going to talk about is the one I'm going to list down now. Like I said, I'm not going to be talking too much about that because I'm only going to be focusing on point. Ideas about diagrams and all those things and videos I can show you from my channel as well on how to actually understand some other things that you need to know. That is if it is needed. But for now, like I said, I will only focus on what I think you need. And what I think you need for now are the major separation techniques and how they work. Now, how do they work? So I'm going to talk by using a table. I think that would be the best way to explain this thing. Let me just do that now. Oh my word. I don't want guy. I want this guy. And I want this guy to be hologram. Okay, fine. So let's do a kind of distinction, differences. Or I want to make it very simple. That's my aim, so that you won't have any problem when you see question. So all this physical process and change of state is also very important. Talking about this change of state, you can see. So other important things are the examples of the separation techniques that we have, the major ones you need to know, and how they work. Because before, I have a video on my channel that I've explained with good diagram on how to actually understand. That is if you are writing WAEC, and thank God all my students here are focusing on UTM. And that is why this class it is so fast and so easy. So I'm going to write this place as separation techniques, separation techniques. I'll just write tech, it's techniques. And here I'm going to write something like property exploited. That is the property we use, property exploited. So that it will be very easy for you to understand. Now, the first separation technique I'm going to talk about is sieving. Sieving. Now, when we talk about sieving is a type of separation technique that is basically that is focusing on on molecules of different sizes. So I will write the property we use in sieving is the particle size, the size of the particle sizes. So when we see the substance, we are actually looking into the size of that particular substance. So the substance that if we want to actually use the method of sieving to separate substances, we must keep it at the back of our mind that particular substance must have different sizes. So when you are employing the method of sieving as a method of separation, you must always note that it must contain different sizes. So when that particular substance has different mixture, has different sizes, then you can think of using sieving as a method. Now, the next method I'm going to talk about here, I'm going to use is popular one, you guys know, sublimation. Sublimation. Now, we have talked by now that when substances move directly from solid to gaseous, or from gaseous back to solid, I say it as sublime. There are quite examples of substances that can perform this this particular process. A very good example of substance that can easily sublime from early classes is you can write ammonium chloride. NH4Cl, ammonium chloride. You can write naphthalene, which is called camphor. Camphor is naphthalene. Very important. I'm listing example of substance that can sublime. I'm just listing that under here, not on what I'm writing here. Now you can also write, I think, iodine crystals. Yes, iodine. Not that I think, I know iodine crystals. So don't mind me when I say I think most of the time. So another substance that can sublime, you can write dry ice. I hope you guys know dry ice very well. That is solid what? Solid what? Ice cube. No, ice we just think directly from what? From gas to solid, or from what? Solid directly to gaseous form. Now, that's that. Dry ice. These are common examples of substance that can easily sublime. But when we want to apply the method of sublimation as what? As what to separate a substance, the property we exploit, this property we look into is that the substances must have the ability to what? To sublime. And what does the word sublime mean? Move from what? Solid directly to gas without passing through the liquid state. The next separation techniques I'll talk about is separating point. Separating point. Separating. But you can see the way I'm teaching it. It's quite different from you taking your Ababio or say Ababio in school and start reading. Now, I am here to give you direct points, what is needed, focus on it. You need to need more. We want to learn more concept. The video, the diagram video, explanation of experiment are available on my channel, which you can watch on my YouTube channel. They are there. But what you need for this exam is exactly what I'm going to teach you from A to Z, topic-wise. And that is why my class is kind of, let me say, comprehensive and what? And straight to the point. And there's no way you are going to fail. That's just the truth. If you can finish with me, if you are not tired. Now, separating funnel. Now, separating funnel is a kind of what? Separation techniques that we use to separate substances that are what? That we say we use it to separate liquids that are immiscible. I just explained that now, immiscible liquid. When I say mixable liquid, that is liquid that does not mix. Or you can say substance with different density. So when when you see substances that you think, this guy cannot mix with this guy cannot mix with this guy, you can always think of separating them with what we call what? The separating funnel. A very good example is what? Oil and water. You guys can just think about oil and water. Oil and water cannot mix. So the best method for separating this type of what? This type of component is by using what? The separating funnel. So liquid that cannot mix, the mixable liquid, we use the what? The separating funnel method as the what? To separate those components. Or you say those fragments. The next type of separation techniques I'll talk about, which I think is very important, is the one that most of you do make for a mistake, the one we call fractional distillation. Yes, I'm going to show you some diagram and experiment on this one soon. Fractional distillation. Now, I'll talk about fractional distillation. The method we use, or the method what we check into that component of mixture that you want to separate is that what are those mixture we are trying to separate are they different in boiling point? We are talking about differences in boiling point. So when boiling point differs, what we use, the method of separation we use is the fractional distillation. A very good example of this one is the crude oil. Separation of crude oil. You guys know crude contains petrol, kerosene, diesel, asphalt, bitumen, and so on and so forth. So when you are separating components of crude oil, you are definitely going to use what? Fractional distillation, because it's actually, I'm going to show you the setup very soon. It's going to contain a kind of what? Different fractionating column. It's going to have what we call a Liebig or Liebig condenser. Then it's going to what? It's going to separate what? The condenser is going to condense the vapor and separate the gas from what? From the liquid. So all these are minimal, but the important thing I want you guys to keep at the back of mind for now is that when you want to use a method of the separation techniques that involve fractional distillation, The key point that comes to your mind is what substances we are talking about must differ in what? In their boiling point. That is the most important thing about what? When their boiling points are kind of what? Kind of not far away from each other, you can think about your fractional distillation. And a very good example is what? The one of crude. Another example of elements that we extract by fractional distillation is the industrial preparation of nitrogen. You can write that. Some other example, industrial preparation, I have to be fast, of nitrogen and oxygen. We use fractional distillation of air. So they are prepared from fractional distillation of air. Because you guys know air is also what? A mixture. So a mixture can be separated because mixture is an example of impure substance. I hope I am communicating. So that means that, guys, another separation technique, I have to be fast, I have a minute more, so I have to borrow from the time. Another example of a separation technique that is also very important is what we call crystallization. Let's talk about that. Crystallization. And when we talk about crystallization, the property we exploited, how do we know that how we have to so what we have to crystallize this particular substance is that we check about the what? The inability of that substance to withstand it. So we can say inability to withstand it. So that means if that thing cannot withstand it, so immediately we add it to it, that guy is going to break down. So if that particular compound is showing or mixture, one of the compound or elements in it has the property of it not to withstand it, we can easily think of what? Crystallizing that particular. Most time we use this method in separation of what? Salt, or let's say in separation of sugar. Please be writing the example. Crystallization are basically used for what? Separation of sugar, because we don't want impurities. Note that. The next separation techniques I will talk about, which I think is also very, very important, is centrifugation. Centrifuge. That's when you get to your, let's say you are going to do some experiment on that. So let's write that centrifugation. So when we want to, how do we know when to use centrifugation? What comes to our mind is what? When we are talking about different particle masses. When there are different masses in that substance, somebody is writing something. Okay, the page is filled. I'm going to help you move up. All right. Now, when we talk about, let me move up about a little bit so that you can see. So I will move it up. Now, I said centrifugation. For centrifugation, we are talking about the property we look into is what? When that particular one of the substance or compound contain particle masses, that is different particles of mass. There are different masses in it. So we are going to take a common, we can actually put it in a centrifuge. I don't know, maybe you guys have seen the method of centrifugation before. I might be showing you some videos to explain that one clearly for you to be able to get that. Then the next one I'm going to talk about, which I think I also need to talk about, is what we call fractional crystallization. It's kind of different from crystallization. Fractional crystallization. Wow. Fractional crystallization. So fractional crystallization, I'm trying to make it neat. Fractional crystallization. Now, for fractional crystallization, we check the solubility of the substance. Fractional crystallization, which some of you call precipitation. So what the property we exploit is that if that particular substance has different solubilities. So when their solubilities are different, so we think about what? Fractional crystallization of precipitation. A very good example of fractional crystallization of precipitation, fractional crystallization is separation of salt. You know, salts definitely have what? Different, say, insoluble salt. separation of insoluble, they have different solubility. So the property we employ in fractional secularization is that if we see that these guys are having what different salt components with different what solubilities, you think about this. Then another thing I can also talk about is chromatography. I think that one is also important. Sorry guys, I'm borrowing 5 minutes from your time. Chromatography. For that, we are checking migration of what? Migration of color. We're talking about migration. We are looking at that's migration means movement. The movement of one layer above the other. How fast can one particular thing move above the other? So we are actually testing the movement of one color. There are different types of chromatography. We have thin layer, we have paper, we have color, but whatever thing you are thinking about, when you think about chromatography, my dear student, always think about colored pigment. That is examples. I'm giving an example. So for example, talk about ink, blood, and so on. So you can separate them by what? Because when you put them in what in their column, in column chromatography, one particular layer will move. So we are looking at how fast one can move above the other. So we are testing the migration of one component against the other component. So other ones which I think I need to talk about, maybe I need to also move, is filtration. Filtration, evaporation, and all those guys are also very, very important. So let's talk about filtration and evaporation. Don't let me believe you just know that. Now, you know when I talk about what's it called? Crystallization. I talk about inability to withstand heat. That is, it cannot actually withstand heat. But when we talk about evaporation, you always need to keep it in mind that what? In evaporation, we are testing about the ability to withstand or resistance to it, ability to withstand heat, or we say resistance to heat. So they can actually, or you can actually heat them, and one particular component from them can actually withstand heat. Now, some other thing I can talk about evaporation and filtration, because I want to add filtration, and I will stop for now. And when we talk about filtration, one thing you must keep about on filtration is that when we are actually talking about filtration, the most important thing is that here there is always going to be a particular substance that is going to be like what we call, let me just explain in a simple language. I'm looking for it in a simple language. There is always going to be one particular substance which is going to be insoluble. That is, there is always going to be an insoluble solid. So if you want to think about can I use filtration for this particular method, you must find out insoluble solid, which we call the residue. I know you guys know what I'm talking about. I'm pretty sure about that. And the one that is soluble, which is a soluble liquid, you understand? Let me just write in this format, soluble liquid, that you call the filtrate. So to understand this very well, there must be what we call the residue. We check about residue. One component must what? The solid substance is always the residue, and also the filtrate, which is the one that has been filtered out. And everybody, in one way or the other, has come across a filter paper. So, my dear student, because of time, there are lots of other things that I can still talk about. If you give me time, or at Onaniwa, you know me very well, I can continue to teach and teach, but because we are actually going to have, we have what we call a kind of time range, and we have a lot of things to also talk about. So I'm going to stop here, my dear student. But now, keep it in mind. Some other things you can actually keep in mind from what I've explained. Like I said, maybe next class, before I start the next topic, I'm going to introduce you to some diagrams to understand better some separation techniques. You can watch some videos on how these things are being carried out. So important fact you can keep in mind is that when we're talking about separation technique, there are sometimes you can see when they say brine. Brine is a mixture. I just want you guys to keep this in mind. Mixture of sodium chloride in water. So, because when you see brine most time, it contains sodium chloride that is dissolved in water. And the best method we use to separate this one is by what? Evaporation. In fact, there's what we call evaporation to dryness, because evaporation has the ability to withstand heat. I just talked about that. So when you say mixture of sodium chloride, how can brine be separated? Brine is a mixture of sodium chloride in water, and most times we use the method of what? Method of evaporation to separate brine. So please keep that in mind, because I didn't give you an example of this. Now, which other thing is there that I didn't talk about? That another thing that cannot withstand heat, another method of separation that cannot withstand it is crystallization. Do I talk about that? Let me check, because I want to talk. I don't want to make. Okay. Now, inability to not to withstand. So all these and many more are going to be seen when we start our question now. So I'm going to give you 5 minutes to relax. You can take water. So now it is time for us to actually go into our question and answer. You can quickly go through all the questions. And also, it's also time for you to ask other questions. Like I said, there are a lot of things that I still don't talk about, but let you know something, that these little things I've talked about is sufficient for you to score everything under this component. So please, for now, I am going to stop, but I am telling you that this does not mean this is the end of what you need to know in chemistry. No, under this chapter, there are other things you need to know, but according to JAMB requirement, I am able to cover all what is needed according to the objectives. You can quickly check it out again. The objective of the class is, at the end of the class, students should be able to distinguish between pure and impure substance. Students should be able to use boiling and melting point as a criteria to define purity of a chemical substance. Students should be able to distinguish between element, compound, and mixture. Students should be able to differentiate between chemical and physical change. Students should be able to identify different properties of the components of a mixture. What are the different components of a mixture? I talked about homogeneity, heterogeneous, mixability, immiscible, density, and the rest. Then at the last process is what? Specify the principle involved in each of the separation methods. Evaporation, I told you evaporation. That means when we are using evaporation, I told you the method involved. There's simple and fractional distillation, boiling point, sublimation, ability to sublime, filtration, residue, and filtrate. One must be what? A residue. Crystallization, I talked about the method of what? Solubility for fractional crystallization. And for crystallization, I told you inability to withstand heat. Paper and column chromatography, I talked about migration or movement or different speed in column. They use different speed. When you talk about speed or migration, think about color pigment. Simple and fractional crystallization, I also talked about that. Crystallization are method that we use in separation of what? I told you fractional crystallization to separate different salts, which is also called precipitation. So please note that. So all these objectives are being covered in just my 1.5 hours class, or you say 2 hours class, almost 2 hours. Now, it is time for you to ask your question in 3 minutes. If you ask question, I'll be calling you one by one. Now, my first person to ask question now is David. David, are you ready? Please unmute your mic and please ask your question. So far, so good. That is the end of the lecture for today. So let's see if you have questions. Any questions so far, so good?
Sir.
Yeah.
Can you hear me, sir?
I can hear you. I can hear you. Your question.
No questions now, sir.
All right, no question. You can mute your mic. Olanrewaju, you are next. Olanrewaju, any questions so far?
No question for now, sir.
No question for now. God bless you. And Newman, Jintes, any question?
Yes, sir. I have a question.
Your question, please.
Where we're doing difference between compound and mixture. Okay. One of the difference is compound cannot be easily separated.
Yes, yeah.
Meaning cannot be easily separated, meaning it can be separated. And
yeah,
all
not
the separation
that it cannot be separated. It cannot be easily separated by physical process. We can use other
And all the
methods to
separation,
okay. You are saying something. Let
I
me
was
hear.
asking, all the separation technique here are mostly used on mixture. So I was asking, is there any separation technique that can separate a compound?
Yeah, there are a lot of separation techniques that can separate a solid compound. But because, like I said, I'm not actually going more into what is not needed. Now, for instance, compound can be separated by different processes. Let me take you back to some of the processes you've heard. Now, for example, a compound we call sodium triisocarbonate 4, that is Na2CO3, can easily be separated by what? The process we call solving process. You've heard about it before. I know that. So, but for now, we are only limiting ourselves to what is needed as part of what you can say as the objective of the class with respect to your syllabus. So compound can be separated, but not by physical means. Now we have to go through some chemical reactions and chemical processes. I hope that is taken.
Okay. All right. Thank you, sir.
All right. Now it's time for you to just have a short break, 1 minute break, just to take water before you start your own work. So it's time for questions, and question time are the most important time for this talk. So question time is next now. Question time. So I'm going to give you 1 minute. Take water, drink water, relax yourself, and let's face some questions. So now I think we are back. I've also taken water. So let's start because there's no time. Time is not on our side. It's time for question. Now, this is the way we are going to do the question. I'm going to call somebody to answer the question. I will be calling your name one by one. Then you are going to give us, you are going to take us through why you think the answer is correct. You are with your note. You can always look back to your note. Then I'm going to also give you my own opinion and my own explanation about the particular answer. So don't be shy. We are in what? You are not supposed to be shy in a learning process. We are here to learn. So, and I told you, the videos are always available at the end of the class if you need them for maybe for revision's sake. So let's start with a question. We have a lot of them. You can see chapter 1 questions. All questions are taken from your past questions. And it's going to be in this order. Now, the first person that will answer my question is going to be David. The second person is going to be Olanrewaju. The third person is going to be Newma. So I'm going to follow that order. So I don't need to call you to unmute your mic. So the first person to unmute mic now, as we can see here, is going to be David. So David, unmute your mic.
Okay, sir.
Yeah, we start. The first question before us. The first question we have before us is this. I believe you can see the question.
Okay, okay. A small quantity of solid ammonium chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of two gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone A, distillation, B, sublimation, C, precipitation, D, evaporation.
There is
Okay.
E decomposition. So what do you think the answer is? What's the answer? Ammonium chloride. I can't hear you, please. What do you say?
I'm coming, sir.
Okay.
I'm coming, sir.
All right, I'm with you. Ammonium chloride was heated. I told you ammonium chloride has one particular characteristic. It's changed from solid, key points, look at it, to what? To gases. Yes. So when something moves from solid to gases, what is that process called? Sublimation. Thank you very much. Thank you very much. Mute your mic. Sublimation is correct to the first question. Number 2, the second question will be answered by Olanrewaju. So, and I think he's having network problems, so I'm not going to wait for anybody. So please, Jim Test, you are the next person to answer my question. I don't have time. We're waiting for anybody. Now, which of the following changes is now Jim Test, unmute your mic, unmute your mic, unmute your mic, please. Unmute your mic. Yes. Now, yes, which of the following physical, you can read the question, please read the question so that I can actually take it.
Which of the following changes is a physical A.
Okay.
Adding iron filling to saturated water. Okay,
Yeah.
aerated water.
Okay.
Adding sodium metal to water.
Okay.
Cooling a solution of iron. Sulfate. Okay, cooling a solution of iron 2 sulfate to obtain dehydrated salts. D. Cooling water to obtain ice. E. Burning domestic gas.
Okay, fine. So that's your question. What do you think is an answer? I'm giving you 45 seconds. Which of this is a physical change? Adding iron filings to water. Iron plus water will give you iron 3 plus hydrogen. We did that. Anything that forms new substance is a chemical process. So what do you think is the answer? Don't let me talk again. Which of them is a physical process? We talk about that. Any change of state is a physical change. Any change of state is a, which of these is a change of state? That's the key word.
I think,
Any change. Okay, you think?
The answer is D. Cooling water to obtain ice.
Cooling water to obtain ice is 100% correct, because cooling water to obtain ice is a physical process because it does not lead to formation of new substance. Do you understand that? That is absolutely correct. You guys
Yes.
are moving well. So the next question will be answered by David. We move in that sequence. David, your turn, please. Please, let's go first. David, I hope you can hear me. Please, I can't hear you. Please don't waste my time. I have a lot of questions.
Sorry.
Please.
By means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride, and I think the answer should be A. Potassium nitrate, B. Sand, C. Lead nitrate, D. Sugar, glucose, D. Starch. I think the answer should be B. Sand, sir.
Yeah, why do you think it's B? B is correct, absolutely correct, 100%. Why do you think it's B?
Yes, sir.
Why do you think it's
because of the residue, and it can be filtered.
Well, very good, because it can be easily. So one particular thing must be insoluble. So we must think about something that will be insoluble in water so that it can be filtered off. So very correct. Sand is correct simply because sand is going to be the residue, which is going to be insoluble and can be filtered off. Very correct. I love that. I love that. I love that. Next question goes to the next person. Jim Tess.
Methanoic acid mixes with water in all proportion and has the same boiling point as water. Which of the following method would you adopt to obtain pure water from sand and methanoic acid? A. Fractional distillation. B. Filtration followed by distillation. C. Neutralization with sodium hydroxide followed by distillation. D. Neutralization with sodium hydroxide followed by filtration. E. Esterification with ethanol followed by distillation.
So now I think it's a kind of technical question for the first time. So we are talking about methanoic acid mixes with water in all proportion and has a similar boiling point as water. That means the boiling point of methanoic acid is very close to water. We know the key fact that the method we exploited in boiling point, we should think about fractional distillation, fine. But then answer, which of the following method would you adopt to obtain the pure water? That is what you want to obtain from sand and methanoic. Now, the key question is, it is sand and methanoic acid now. So how do you do that to obtain a pure water from a mixture of sand and methanoic acid? What do you think will be the process, and why do you think the answer? So which answer are you going to be? Are you picking? And why do you think that is the answer?
Hey, give me time, sir.
Okay, I'm giving you time.
Yeah, so I give you time, sir.
No wahala.
Right. If sand.
Okay, so I think
I'm with you.
I will go with filtration followed by distillation.
Okay, you are thinking you are going with filtration followed by distillation. That is option.
Wait,
okay.
B, yeah.
Option B. I'm sorry, you are wrong. Yes, it is wrong. Now, the reason why this is kind of technical, I'm going to explain to you. I think the correct answer, not that I think I know, the correct answer to this question should be this guy, option C. And the question is, why is this C? Now, the metanoic acid, listen guys, metanoic acid we have here, we are going to first of all neutralize it. Let me show you how it is being done. Neutralization is, metanoic acid is, neutralization means when acid combine with what? Base. What is the base? Let's use what? Neutralize with what? Sodium hydroxide. So when we react metanoic acid for what? With sodium hydroxide, this is a neutralization reaction. We are going to have a sodium metanoate. We are talk HCOO, Na, that's salt and water. Are you guys there? So if we have salt and water, this particular compound HCOO, Na that we are having here, that is formed, is said to be what? This guy here is a soluble, salt. So this compound sodium metanoate is soluble, but the only thing is that what? It is not as volatile as this metanoic acid. So why we need to actually neutralize it is because we need to get water before we can now think about any other method. So what we now do next, after neutralizing it, you know, we're having this component and we're having a salt and water. This component I said is salt, but not as volatile. It cannot be what? When I say volatile, volatility means what? Evaporation. When I say volatile, the word evaporation does not easily evaporate. This particular guy here easily evaporates. This is methylated spirit. Everybody know methylated spirit easily evaporates. So this one easily evaporates. But this guy here is not what? Is not what? Does not easily what? Evaporate. Substance that easily evaporate are called volatile liquid. Listen, and that's why questions will actually help us. So because this one is not easily evaporated, so the next method we are going to do after doing this is that what we are now going to what? We are now going to what? Follow the method of distillation. Why are we following the method of distillation? This is simply because it will now have what? Higher boiling point than that of what? Than that of what? The initial organic compound. So this particular substance we are forming is now going to have a kind of high boiling point compared to the initial what? Initial metanoic acid, which is the organic compound. So the correct order should be, first of all, neutralize it with sodium hydroxide so that you can form sodium metanoate, which is more soluble and have high boiling point. And we have talked about when substances differs by boiling point, the method that comes to our mind is the method of what? Distillation. So the correct answer to that is neutralization. Why do we need to neutralize? Because initially these two particular substances, the substance here is having what? Boiling point that are too close. And apart from that, we want to separate sand. Now we want to obtain water from a mixture of sand and metanoic acid. The first thing is, let us what? Add sodium hydroxide to neutralize this guy. Then we let us get this guy. This guy is soluble. Then let us filter off. So when we filter off, we know when we actually go by the method of filter, when we go by the method of distillation, we are going to have what we call what? Liquid. You know that very well. And that is why. Now, you cannot say you want to follow, you pick B. And B here is a filtration followed by distillation. Now, if you filter sand, what will happen to the metanoic acid? That's the problem. You know, you want to obtain water. So this method will not work. Because how do you want to obtain water? When you add water to sand, what happens to the water? Metanoic acid is also what? It's also liquid. And it's a volatile liquid. So it's not going to work. If you filter it, you are still going to have a mixture of metanoic acid in your component. So that is not a good method. The best method is neutralize it so that you have a new compound which you can easily now what? Now separate. You can say the compound here on its own is going to have sodium metanoate and water, which can easily be separated by fractional, by distillation. So that is that about that. The next question, because of time, we need to increase our pace. David, next question, please. David, the next question, please. Yeah, please, let's go fast.
One of the following techniques can be used to show that chlorophyll pigment is a mixture of chemical compounds and not a single colored compound. A. Crystallization.
You know what?
B.
Don't let us waste time. Don't let us waste time in reading question. Just read the question, don't read the options. Now, the key point here, because of time, I don't have time on my side. I have to increase my pace. Now, it's a simple question. We are talking about colored pigment. The key thing that comes to your mind is colored pigment. What is colored pigment answer?
Chromatography.
Chromatograph. The next question. Now, the next question, mute your mic. The next question is going to answer by Jim Test. Jim Test, please read question, leave the option. Yeah, please, I'm waiting. Jim Test, so I'm not hearing you.
Sorry, sir. I had a camera to tell it. So, all right, sir. I should answer the next question.
Yes. Read the question and answer. Don't read the options. Yeah, please. Yes, let's be fast, please.
In an attempt to remove sugar from a beaker containing a quantity of sand and sugar, 2 millimeter. Is it millimeter?
2 molarity. This is molarity. Yeah.
2 molarity ammonium chloride solution was accidentally added instead of water. Which of the following method can be used to remove ammonium chloride from the mixture?
So I think it's a simple question. Don't read the options for me. So what do you want to remove? Ammonium chloride. So similar question as what you've done before. What will be the answer? Let's be fast. We have a lot of questions. So what will be the answer to the question, please? The order is very, very important as well. Yes, you have sand and sugar before. Then ammonium chloride was now added instead of water. So then I say, how will you remove what? Which of the following can be used to remove ammonium chloride? So what do you think will be the answer?
I wanted to say filtration, but
no. There is ammonium chloride. Ammonium chloride is a substance. You did that here. See, ammonium chloride is a substance that can what? That can sublime. So that one is very, very important. So the first thing is to say, what can you do to sand and sugar? Can they withstand heat? Yes, they can withstand heat. So what do you do?
Yes.
What do you do? Eating them, Abby. What do you do when you eat them? To dry off what? Water. So when you eat them, you are going to dry off water from them. They can withstand it. So eat them, that is evaporation. So to dry off water, then what? Ammonium chloride, when it is dry, ammonium chloride will now sublime. You understand? These two guys, eat them. I get it now. When you eat, to actually remove water from it. Can you hear me?
Yes.
Okay, fine. Now, the question is, which of the following method could be used to remove ammonium chloride? Now, ammonium chloride was added instead of water to this solution. The solution contains some amount of water before. So what you need to do is to heat them, and they can withstand heat. That means you are going to use the method of what? Evaporation. I told you the method we employ when one particular substance can withstand it is evaporation. Then after you have dried them, as in you have absorbed all the water components in there, you know it's a solution before. So when solution will always contain water, you know that. But instead of them to add more water to it, they now added ammonium chloride. So what you now do is what? When that thing is now dry up, after it has been evaporated to dryness, then ammonium chloride will now sub. How does it sublime? It changes from solid form directly to gaseous. You understand? So what will be the answer from that explanation? So this will be the right answer. The answer will be what? Evaporation followed by sublimation. So David, next question. Let's be fast, please. We don't have time. Time is not
which compounds and elements would sublime on exposure?
So what's the answer? Don't waste time.
I'm thinking of sulfur. Or
don't think of two answers. You have to think of one answer. I gave you all iodine. I gave you all those things. I told iodine crystals when I was listing. And if I don't list, maybe you add it to substance that can sublime. I don't even know where I've written that, but I know, say iodine crystal. So your answer should be what? Solid form of iodine is what is going to sublime. No need to waste time. Jim Test, your next question. Let's be fast. Next question, please. This is not the end of the questions. That's what you need to know. There's still one more page. Yeah?
The page has changed.
The page has changed. Then I've changed the page again. Yes. Maybe your network is so slow.
All right.
Check.
This is my network.
Yeah, it should be your network. Who can see the page now, please? David, can you see the page I have?
I can, sir.
You can. Okay, David can see, please. Please use the room time. Now, Larry, you can help us. The next question is this, I'm highlighting and my mouse is pointing. Please read for us, read for us, thank you.
Which of the following process does not lead to chemical change?
So what does that question is asking us? Which of the following does not lead to formation of new substance? So that is, which of the following process is a physical process? So guys, don't waste my time. Atlanta, what do you think the answer will be? Read the option in your mind. Don't read it to me. Which of them does not lead to what? Chemical change. That is, which of these options is a physical process? Which of them does not lead to formation of new substance? So which of them do you think? The only one you can think of, I don't want to waste time, is what? Steering. When you are steering substance. Steering substance does not give you what? You know that very well. Steering of what? Sodium carbonate in water. If you steer something, if you steer sodium, steering is what? Steering of Na2CO3 with water will not give you a new substance. All this here, steering of iron plus sulfur will give you iron sulfide. Steering glucose, I told you this one is churning of what? A bit churning of what? Churning of what? Glucose. It's going to give you carbon black. We talk about that. Rest. Mixture of sulfur with potassium carbonate is going to give you what? A new substance. Titration, acid against base. Abi, definitely is going to give you, when acid reacts with base, it's going to give you salt and water, a new substance. So the only substance here, sodium carbonate reacting with water. Sodium carbonate reacting with water is not going to give you, because sodium carbonate is said to go not to dissolve in water. So because of that, it's a physical process. Do you understand that? I believe you understand. David is the next person. David, the next question, please. No time. David should be the only person that his mic is muted. David, please. David, please read.
A mixture, sir?
I'm with you. A mixture.
A mixture of common salt, ammonium chloride, and barium sulfate can be tested by. It can be separated.
Can be separated. Okay.
Let me read the question. Let me read the option in my mind.
Whenever you see ammonium chloride, think about sublimation, salt, and barium sulfate is what you are going to look into. Like, what can I do? Okay, I know everybody knows how to separate salt. I can think about evaporation or filtration, but the barium sulfate that is contained inside is something, that means barium sulfate will be insoluble. So when you have insoluble substance, what comes to your mind is filtration, because barium sulfate is not soluble. So what do you think the answer will be? I'm waiting for you, and I want you to be fast, please.
Fractional crystallization, sir.
Never. How would you fractionally crystallize this? I told you ammonium chloride can sublime. Now, barium sulfate is not soluble. As in, barium sulfate is not soluble. So if you have a insoluble soda, you can add water to. So that means when you mix the mixture of salt and barium sulfate, when you mix them together, you can easily separate salt and what, when you mix what, barium sulfate will be easily insoluble in salt. And what you are going to have is what? You can easily filter up the filtrate, which will only contain what? Sodium chloride. This is what I'm saying. Ammonium chloride is going to sublime. Sublimation is the first paper. Now you are left with what? Common salt and barium sulfate. Now you know that whenever you are having at least one insoluble substance, get it? One insoluble substance. What you can think about is what? Barium chloride, or whatever they are saying, barium sulfate or barium chloride, I don't know what is written, is insoluble, and you can filter it off. Then you should know that what? The filtrate will only contain what? Common salt. So when you filter barium sulfate, the filtrate will only contain what? Common salt, whereby the residue will be the barium chloride and the barium sulfate that is written. So the best method is for you to allow this guy to sublime first. After this one has sublime, has left, then you are left with common salt and you can separate common salt and barium sulfate by using the method of filtration. How do you filter up? You add water to them. When you add water to them, the filtrate will be common salt. The residue will be what? Barium sulfate. I hope you guys are getting my explanation. So that is the method you are going to use, and it's as simple as ABC. The next question is for gym test. Gym test, Your question is this. I think we've talked about this. Don't waste my time. Please read. James, are you there? Yes?
Yes. The answer is evaporation.
Very good. Sodium chloride may be obtained from brine by what? Evaporation. It was in your examples, and I love that you didn't waste my time. So guys, you've done so well. So the next page is where you guys are going to write your answers. You are going to answer the following questions. And when you are through, you only have 5 minutes to answer them, and we are going to do this solution. So I'm going to give you 5 minutes to do this. Fine. So these are your questions you are going to answer. Nobody is talking to anybody. You mute your microphone. Your time starting, and by 9:44, I am going to stop you. So please start solving. Just write your answer A, B, C, or D, or whatever. Then we are going to put it together. Then you are going to mark yourself. So that's what you are going to. So this is the next set of questions. Attempt on your own, please. So if you are true, you can just use the room chat. You can just use the room chat. You use the room chat. What I mean by using the room chat is you write your options. This is like the first one. This is like the second question. This thing is just taking space. This question 1. You just write 1, maybe B, 2, C. This question 2. This is question 3. This is question 4. This is question 5. This is question 6. This is question 7. This is question 8. So you have 8 questions. So just drop your answer in the room chat, please. Don't waste my time. We are stopping this class by 10. You guys know. So we have 18 minutes more to the end of the class. It will stop automatically. So I don't want you guys to just, you know. So you have 2 minutes more, less than 2 minutes more now. Drop your answers to the inside the chat box. Drop your answer inside the chat box. 1 minute more. 1 minute more. So time up, time's up, time's up, time's up. So let's start. Please, your answers. I need your answers. Let's start with David. David, are you there? Unmute your mic, please. So let's
Yes,
say,
sir.
let's start. Number one, what do you pick in number one? No time. I don't have time again, please. Just answer my question.
Okay.
I'm doing the correction. What do you pick in number one? Just tell me your answer, please.
Number one, I pick B.
B. B,
Yeah.
okay. Jim says, what do you pick in number one? I just want to compare answers before I talk.
I pick A.
You pick A. And Larry, what do you pick in number one?
B, sir.
You pick B. Okay, fine. Let's see who is correct. Now, the question says X, Y, and Z. Everybody know X is moving from solid to gas. Look at the arrow. That is sublimation. So sublimation can be A or B. Then Y is moving from gas back to liquid. When something is moving from gas to liquid, what is the process? It is not vaporization. So people that pick B, you are out of the contest. So only Jim test is correct. When substance moves from gas back to liquid, what is that? Condensation.
I wrote
gas back to liquid. Please, just mute your mic, please. Mute your mic. This is what I hate feedbacks. Mute your mic. When I'm talking, mute your mic. Thank you very much. I don't want feedbacks. Now, when substances move from what? From gas. Look at Y now. From gas back to what? Liquid. You have it in your note. So Jim test, I think you are the only one that is correct. And the third one is freezing. What happened? The third one is moving from liquid to solid. Solid to liquid is melt. Liquid to solid is what? What's liquid to solid? Freezing. Abi, freeze. Freezing. So thank you very much, Jim test. I love that. Thank you very much. Thank you very much. Question 2. Larry, what is your answer for question 2? What do you pick in question 2? I don't have time, so please don't waste my time. Just answer me. You are the only one to unmute mic. Please, please, and please. Not to think. Don't think of any answer. What's your answer to number 2, Oga? Oh, yeah. Can you hear me? Unmute your mic and talk. I'm not hearing you. David, what's the answer to number 2? David, what's the answer to number 2, please?
I pick D, sir.
You pick D. Okay. Mute your mic back. You pick D. D. Okay, fine. Jim test, what's the answer to number 2? You are not reading through your note. What's the answer to number 2? Jim test.
I chose D too.
You chose D. D, Abi. Which of the following can be obtained by fractional distillation? I told you this. See, I gave you this. This particular thing was mentioned. I will show you because I don't have time. Doesn't make me not to go back to what I've talked about. See, fractional distillation. I'm going to show you. See, fractional distillation example. See, I said fractional distillation example. That is crude oil. I also say what? Industrial preparation of what? Nitrogen and oxygen. They are what? They are prepared for what? Fractional distillation of air. So which of the following can be prepared by fractional distillation? That is why you need to practice. Yeah, I love that. Look at it, nitrogen from liquid air or liquefied air. So fractional distillation is one of the methods we use to prepare nitrogen from air. So please note that. It's not the end of the world. You miss a question does not mean you don't know book. So I don't know why I'm calling somebody is not responding. It's so bad. I will remove anybody I call and is not responding. Doesn't make sense. The next question. David, please, what is your answer to the next question? What is your answer to the next
which
question?
of the following are my answer
yes.
should be
What do you think is a mixture? I can't hear you. Talk.
should be petroleum.
Anything that cannot be represented in a simple formula. Anything that cannot be represented in a simple formula is a mixture. Anything that cannot be represented in a simple formula is a mixture. So what do you think? You can represent carbon 4, carbon 2 sulfide in what? In a formula. You can write that one as CS2. That one can never be a mixture. That is a compound. Fine. Can you represent rubber in a what? In a simple formula? Can you represent petroleum in a simple formula? Can you represent vulcanizer solution in a simple formula? If not, all those ones that cannot be represented in a simple formula is said to be a mixture. So which of these is a mixture, my dear student? What is the answer? I am waiting. Oh. David, I can't hear you again, please.
Sorry, sir. My answer should be then
you are thinking. I think well.
Sir. Sorry, sir. Yes, sir.
What do you call it? A or B?
Yes.
Correct. A is correct because every other guy here can be represented as a simple something. Only this one cannot be represented only. So that's the logic to know mixture and that. See, please, whenever I teach you a particular topic, one joy about my own class is that I will give you questions, all questions you can see on them. So you shouldn't have problem if you are following. Now I know you are going to be getting used to my type of class. And that is the essence of coming on a secret this thing like this to teach you. Because we are exposing what you are going to see during your exam. So don't feel so bad to actually answer my question. If you are here, you are not answering my question, I will remove you. That's one thing about me. And if you miss my question, I even want you to mix them so that I can explain better. Nobody is here to check me that somebody knows book, somebody does not know book. So you speak. When I ask you to answer a question, you do that very quickly. I have 9 minutes more to use here. I keep to time. Your class starts from 7:30 and ends by 10. The next question. Now, the next question is, which of the following is going to be answered by gym test? Which of the following substance is not a homogeneous mixture? Which of the following substance is not a homogeneous mixture? Now, homogeneous mixture simply means uniform mixture. So we told you mixture can be uniform and can be what? Heterogeneous. That can be what? They can also be what? They can be in different phases. So which of the following is not homogeneous mixture? Now, all options here cannot be written as a simple formula. They are all mixture. But which of them is not homogeneous? That is, which of them is heterogeneous? That is, which of them it has different phases, different constituents. So what do you think will be the answer at gym test? Different constituents.
I chose C.
It was C, right? Do you say C?
Yes.
Correct. Flood water is the only one out of these that is heterogeneous because it contains different constituents. Very correct. I love that. Because when you have filtered the seawater, definitely is going to be homogeneous. Salt drink, definitely homogeneous. Writing ink is homogeneous. The only one that contains different constituents here is the flood water. Thank you very much. The next question will be answered by David. David, question 4. Don't waste my time. Don't read any question for me. Brand of ink. The keyword here is ink. How do you separate ink? Colored pigment. What is the answer? Don't waste my time. David, unmute your mic and talk, please, please. Ink is colored pigment. Which method is what? Chromatography. Thank you very much. The next question will be answered by gym test. Gym test, which of the following substance is a mixture? We have answered this just now. You talked about it. The answer you pick, which of the following is a mixture? The only one that you cannot actually represent it by what? By a simple formula. Sugar has a formula, 6 is H12O6. Sodium chloride has a formula, NaCl. Iron finance has a formula, Fe. Fe2O3, Fe3O4. So now, but seawater don't have a particular formula. So definitely this is going to be the answer. Guys, are you getting it? Gym test, do you get that? The answer is going to definitely be what? 100% B. The next question is going to be answered as Olanrewaju. Unmute your mic and talk. The next question here, we have a diagram. The key things you look at is what? Ammonium chloride. What do you also see? It was solid before. When heat was applied to it, it turns to gas. So when substance moves from solid to gas, what will be the answer? Don't read any questions for me. What is the answer? Sublimation. Please, I don't want, mute back your mic. Mute back your mic. Thank you very much. Next question will be answered by David. At David, question 7 says, I will read. Just answer, give it the option. Which of the following would support the conclusion that a solid sample is a mixture? I told you for a mixture, there are some particular something about mixture. Now, the solid can be grinded to fine powder. Does that one tell you that it is a mixture? The density of a solid should be 2.2 grams per dm³. Does that tell you that it is a mixture? The next one says, the solid absorbs moisture. Okay, the solid has a melting range of 300 to 375 degrees Celsius. Does that tell you it's a mixture? The solid absorbs moisture from atmosphere. Does that tell you it's a mixture? Which of these is a criteria that helps you to know something is impure? One of the criteria for pure substance or impure substance should be what? Melting point. So what is supposed to come to your mind in this type of question should be melting point and boiling point. So out of all the options, which options do you think will be the best answer that will prove that a solid substance is a mixture?
C, sir.
C. Why are you going for C? Because I told you that what solid substance actually have what? They do have what? A particular what? Range of what? A particular range of temperature. About 600 and something to 600 what? 500 and something to 600 and something Kelvin. But if you look at this option, the examiner put the answers in Celsius and not in Kelvin. You are correct. You are correct. 4 minutes to the end of the class. Now, the next question will be answered by Larry. Larry, please give us answer to this. You don't need to read. Which of the following is a physical chain? Don't waste my time. Physical chain. Physical chain does not lead to formation of new substance. So I don't think you should. When you pass steam over heat oil, it's a physical change. Jim Tess, what do you think is the answer? That is wrong. I'm sorry. Mute your mic.
C.
Jim Tess, what do you think is the answer?
C. Dissolution of sodium chloride.
Sodium chloride in water. I told you when you put salt in water, because you didn't start with us, salt in water is a physical process because you can easily separate that. Every other substance here, or every other options here are definitely going to give you a new substance. You put chlorine in water, you are going to have hypochlorous acid. You what? You dissolve what? Sodium chloride. You dissolve a chlorine into a bar containing hydrogen. You are going to have hydrogen chloride. Now you pass steam over heated iron. I gave you that the other time. Do you remember? You are going to have iron 3 and what? And hydrogen. So every other this thing, when you dissolve, when you bubble, but the only thing is, if you dissolve salt in water, salt and water will not give you new substance. You can easily separate it. So the answer is 100% C. So that is that about that. About your practice question, you can mark yourself. I am not after what you get, when I am after you going back to those topics and checking them again, looking at the questions we have solved and see if you are still going to have problems. So the last phase now is going to be your assignment. Let me let you know this. I take my assignment very, very, very serious. If you don't do my assignments, in fact, I will remove you from my class. That is what I do. So the next week now is going to be your assignment. What you are going to do, because you can't be writing, is that you are going to screenshot. You can enlarge your screen on your phone. You are going to screenshot, then you attempt all the assignments. That is where I'm going to start in my next chemistry class, which is going to be on Friday. So I'm going to do the assignment because next chemistry class is just 1 hour, 30 minutes. Because I also have physics on Friday. You can see it from the timetable. So what we are going to do now is to go to the next slide and show you the last set of questions, which are your assignments. So as you can see, guys, this is your assignment question. But what you do now is just for you to screenshot. 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 If you are done, you can write done in the room chat. Screenshot because there are still more questions. Just write done in the room chat. If you are done with the screenshot. If you are using your phone, you know how to screenshot. If you are using a laptop and you don't know how to screenshot, let me know. Write in the new room chat. I can take you through how to what? How to screenshot with a laptop. Okay, done. Done, 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 done. So I can see Jim Tess and Olanrewaju. are done. David, what about you? Are you through with the screenshots, David? Okay, fine. Now, the next page is also your assignment, which you're also going to screenshot. Fine. So this is the one. I can help you enlarge it. So that, but if I enlarge this, you can enlarge it on your own stuff. So this is the last part. Screenshot. If you are done with this as well, you drop done. Screenshot, please. So you can see your assignment. So by doing all these assignments, they are repetition of what we have done. Most of them are just being repeated from the JAMB pack, and you can see the year there. So this is the end of today's class. It's exactly 10 o'clock. And I'll be meeting you on Friday. You have the timetable with physics first and also chemistry to finish up with this. So guys, if you have anything to ask me, if you have any problem, the videos are available. If you need it, you can send me a message on my Telegram, and I'm going to send the video to you. On the other hand, you can also watch the video on what? On the YouTube page, it will be uploaded. But I don't upload everything because you guys are paying. I cannot be leaving everything for them free of charge. So if you need all the full video, you want to watch it again, you want to listen to it again, you can just send me a message on Telegram and the video is going to be yours. So somebody is talking, yes, and I can see Dawn. Okay, fine. Very good, you guys are done. So we are going to stop this class. Tomorrow you have biology class. Your biology classes are going to be on WhatsApp. Please, you don't come late. When you are there, you let the teacher know you are there. Biology class is tomorrow, 8 to 10. Your teacher is a disciplinarian. He doesn't take rubbish. So if you are not there, he might decide not to be taking you guys' classes again. And it is you that guys that you want to learn. So please note that there's a biology class 8 to 10 tomorrow. I'll see you tomorrow by the grace of God. I'll be in that class, but I will not talk. And if you have any question, you can drop them for me on my WhatsApp. Attempt all this. See you guys soon. Do take care of yourself. Bye for now.